Hello friends, welcome once again to ASOMNOF Online Maths. In this particular video, I'm going to continue with my works on inverse functions, and today I'm going to focus more on inverse function. Before you talk about the inverse function, you should know more on the word inverse or the inverse element. Inverse is just like a reciprocal, the other way around. That's the meaning. Okay, so if you talk about the inverse of a function, it's just the reverse of the function. Supposing you have a function like, so if you take a look at this particular function, you will see that f is a function of x mapped into y. And a good observation will tell you that a is mapped into n, b is mapped into m, c is mapped into p. That this type of function is one-to-one mapping, because every element of the domain has a unique image in the codomain. The image of A is N, the image of B is M, the image of C is P. So every element in the domain has a unique image in the codomain. All right, so you can take the other way around. Assuming I have a mapping here. So if you take a look at this second mapping, that is the map, G is a mapping of Y mapped into X. You understand that this is just the reversal of this. The domain here is the codomain here, while the codomain here is the domain in this particular case. So this is the inverse map of this particular mapping here. The inverse mapping is this. And we observe that this kind of mapping is also onto mapping. In onto mapping, you see that all these images are, every element here are having a codomain, are having an image in this codomain. Okay, and no element is left behind here in the codomain. So you see that all the elements in the codomain has at least one is mapped into one element in the domain. So this mapping is both onto mapping and one-to-one mapping. Therefore, for you to say that a mapping we have an inverse, it must be one-to-one and also onto mapping. Now take a look at this particular mapping here. Now, if you take a look at this particular mapping here, you will see that H is a mapping of A into B. These are the images of the elements of the domain. Okay, now if I try to find the reciprocal, turning it the other way around, I'll have something like this. Okay, now if you observe the inverse of the mapping of this one, you understand that this particular, I won't call it mapping, this particular diagram we have here is not a mapping, because P is having two images. Every element must have a unique image. No element should have up to two images. You can see that when we reverse this, we got something that looks like this, where P is having two images, which is not an attribute of a good mapping. Therefore, this is not a mapping. Hence, the reason we say that this does not have an inverse is because it is not both onto and one-to-one at the same time. But in the above, this is one-to-one and also onto mapping. That was why it was able to have an inverse. But in this case, this is not one-to-one, since C and D are sharing the same image. And because of that, this particular mapping does not have any inverse. In my next video, I shall work on how to get the inverse of a given function. Thank you for viewing, and may God bless you.